Didn't start recording, sorry. Okay, so if that's all of our information, and this is our picture, this is R, L, A, and then we have P, S, and I. Almost spells praise. We should just make the L and E. But that's just gonna mess everything up, so we won't. We'll pretend. Okay, so first thing I want you to just take a look at is what we know, and then what we're trying to prove. Okay, so we know that AR, so this side here, is congruent to this side here, right? That's this information. We know that PR, so this part congruent to that part, that's this information. And we're trying to prove that AS, so AS is here, and LS is here. Okay? So a lot of different pieces of information. If you look at what is given to you, the two triangles that have the blue and the red, would be, I'm going to rewind on all of the coloring just so I can show you now what I just wanted you to see where all of our given information is. The two triangles we'll be working with will be this triangle here, right? Because we had two of those sides. And then the other one will be this triangle because we had two of those sides. So we're going to start there, even though what we're trying to prove is not part of those two. Like I said, we're going to use two different sets of triangles here. So if we draw our two triangles, and try and make this a darker green. All right, so for our first triangle, we have this one. I don't know why some days my lines are just so much more squiggly. I didn't have coffee. Okay, so that's RAA. And then the other triangle, the red one, would be this one, which is R, P, and L. Okay, so we're going to start here and we're going to look at our given information. So the given says that AR is congruent to LR, so mark those congruent. And it says that PR and IR are congruent, so PR and IR are congruent. Okay, so step one, given. We know all that information. What do you need to look for in overlapping triangles? What? Common side or angle, right? We're looking for the reflexive property. So do you see something that is reflexive here? Angle R is the same in both of those triangles. So we can say angle R is congruent to angle R by the reflexive property, which means we can say that triangle ARI is congruent to triangle, so if it's ARI, it's got to be LRP. Why is that? Whenever you prove triangles congruent, what are you using? SAS, SSS, one of those. This is side angle side, right? Because it's the included angle, so SAS. Now here's where you have to look at what it is we're trying to prove, okay? We're trying to prove right now that AS is congruent to LS. And if you look at that, AS and LS, those are both parts of these two triangles, right? Which we're not working with yet. But the triangles we just used have something in common with the triangles, the blue triangles I just drew in. Do you see it? the angles, right? These bottom angles down here, this angle and this angle, are the same in those smaller triangles and the bigger triangles. In other words, it's reflexive there, right? But we don't even have to use the reflexive property because we're going to prove the triangle's congruent and the part's congruent. So the next thing we're going to say is that those two angles are congruent because it will help us in our next set of triangles. So angle PSA, nope, sorry, PAS. Angle PAS is congruent to angle ILS. And how do we know those two angles are congruent? How do I know these angles are congruent? Not given, CPCTC, right? We proved the triangles were congruent. Therefore, we know the angles are congruent by CPCTC. So if we know that, now if I look at these other two triangles, so we're going to redraw the other two now. That's not great. Try again. Still not great. Okay, so if we know this is P, S, I, L, and A, we just proved in this last step that these two angles are congruent. Okay? We have to figure out enough information now to prove the triangle's congruent so that we can prove AS congruent to LS. So is there anything else about these two triangles that we know to be congruent? There's vertical angles. So we can say angle PSA is congruent to angle ISL because they're vertical angles. Okay, and then this next step is a little tricky. Yeah, the best way I can give it to you here is this. I can actually say right now that those two sides, PA and IL, are congruent. Does anyone see why? How do I know that this is the same as that? Or how do I know that this is the same as that? Yeah.
Third angles theorem and then CPCTC.
Third angles theorem wouldn't work because AAA isn't a postulate.
Oh,
I'm saying, how do I know?
because they're part of their first triangles.
Right, they're part of those first triangles, which means because I knew that this whole segment up top, AR, was congruent to IL, and because I proved earlier that this smaller one, RI, was congruent to RP. So because they told us both of those parts are congruent, then the other part to them has to be congruent as well. Do you know what that is? It's segment addition postulate. So basically what we're saying is because I said, let me highlight here so you can see the parts that I'm talking about. This part here, PA, is what we're trying to prove congruent to IL, right? Well, because we knew that RA is congruent to RL and RP is congruent to RI, those parts added to it have to be the same to add up to the same thing. Does that make sense? That one's a tough one to see. So if that's the case, then for step 7, I can now say from this picture that triangle PAS is congruent to triangle ILS how do I know these two triangles are congruent? Look at your markings there. What do you have? AAS. Okay, so if the triangles are congruent, then everything about them would be congruent, including what they wanted us to prove, that AS and LS are congruent by what? CPCTC. Okay, so it's almost like you did two proofs, right? We got to this point, proved those two triangles congruent, and then we moved on to our other set of triangles to prove what we needed to prove congruent. Okay? I promise they're not all 8 steps long, but that one just happens to be a pretty long one. The second one that we're going to do is shorter. It's only 5 steps. Let's lay that one out. All right, let's say we are given that AE is congruent to BE, and angle C is congruent to angle D, and we're going to prove AD congruent to BC. And here's our picture. Here it is. First step is what?
Given.
Please don't make me cry on the test. Free points. Given. So this is going to go here as our given. Look at what it is that they're giving us. They're giving us AE congruent to BE and C congruent to D. So AE and BE and C congruent to D. Those, oh, I never thought of it that way. Yeah, that doesn't really help us. So those are both parts of two triangles, but that doesn't actually help us to get AD and BC because those aren't parts of those triangles. But instead, where I want you to start, anyone see where I want you to start?
Vertical angles.
You could do vertical angles. That's what I was going to say. You could go that route, and then you'd have AAS, and you've proved those two triangles congruent. But that doesn't get you to the bigger triangles. I'd have to think through if there's another way you could get there doing that. But I don't see another one. Well, I guess angle, no, that would be donkey, so it wouldn't work. But it's a good thought, right? Because there are vertical angles there. However, that's not going to get us to the triangles being congruent. But what do you know about this triangle?
It's an isosceles.
It's isosceles. So in an isosceles triangle, what do we know to be true?
Because the two sides are congruent, then B and A must be congruent.
Yeah, EBA and EAB, right? These two base angles are going to be congruent because it's an isosceles triangle. So that's where we're going to start here. We're going to say angle EBA is congruent to angle EAB. And that's just the isosceles triangle theorem. It says if the two sides are congruent, then the base angles are congruent. Okay, so now if you look at our picture, if we're trying to prove AD and BC congruent, those are parts of these two triangles. So I'm going to break up my triangles into this triangle here, right? That has BC as part of it. So that's going to be this triangle. And now look at what we know already about that triangle. We already know this angle. We know this angle. So we know those ones so far. And then our other triangle, we'll make it the green. Our other triangle would be this one. And that would be ABD. So here's B, here's A, and here's D. And in that triangle, we have this angle double marked, we have this one single marked. Is there anything else you know to be congruent in those two triangles?
We know halves of things.
You know more than that. There's something that you know is congruent.
The vertical angle.
No. They're overlapping, right?
Oh, the shared side.
The shared side, which is what? BA. So we can say that BA is congruent to BA by what? The reflexive property. Okay, and what we were trying to prove is that AD, so this side here, is congruent to this side here, which I'm not going to mark because I don't want to throw off your labeling here. But based on what we're seeing right now, we can say that the two triangles are congruent. So ABD is congruent to, if I go ABD, I have to go BAC. Why do I know that? What do your markings tell you? Why are the triangles congruent?
AAS.
That's AAS. Okay, so then we can say that the parts are congruent. AD is congruent to BC by what? CPCTC. Okay, so these ones are harder. They just are. There's like double overlap going on. The good news is you don't have to do a double overlap one on the test. So don't stress that if you're not getting this, you're going to bomb your test. You're not. There is overlapping triangles on the test. So you're still doing the principles you're going to see on the